Download this code from codegive.com, link in the description below. OK, let's dive deep into the world of buggy vectorization using Insight Maker. I'll provide a comprehensive tutorial, highlighting the potential pitfalls and how to work around them within Insight Maker's framework. I'll also include code examples that illustrate the problems and solutions. Understanding buggy vectorization in Insight Maker. Insight Maker is a powerful system dynamics modeling platform. One of its most attractive features is its ability to handle large amounts of data, often by running simulations on many entities or using different scenarios simultaneously. This leverages the concept of vectorization, where calculations are performed on entire arrays of values at once rather than one at a time. Ideally, this leads to a massive speedup in simulation time. However, Insight Maker's vectorization implementation isn't perfect and can have some surprising behaviors, particularly in situations involving 1. Circular dependencies * when a variable depends on itself directly or indirectly within a single time step for different elements of the vector, the results can be unpredictable and potentially incorrect. This is because the order of calculation for elements in the vector is not guaranteed. 2. Delay and similar functions * delay functions inherently rely on time-based state. When used with vectors, you can encounter issues with the delay propagating correctly across all vector elements. This can lead to incorrect or inconsistent time series. 3. Lookup functions with vector arguments * lookup functions can sometimes behave unexpectedly when the input is a vector. The lookup may not properly apply to each element of the vector as intended. 4. Integ functions, accumulations, with complex dependencies * integration functions can have issues when combined with vectorization and complex dependencies. 5. Nonlinear functions and initialization * if you're using nonlinear functions, example exponential growth, logarithmic functions, with different initial values for each element in a vector, the results can be very sensitive to the initial conditions, and any problems in the computation can be amplified. Illustrative example, population growth with individual carrying capacities. Let's create a simplified example to demonstrate the core problem. Imagine a population of individual insects in a box. Each insect's growth rate is affected by birth rate * a basic constant birth rate. Carrying capacity * each insect lives in a box with a different carrying capacity. We will define a vector of carrying capacities. Here's how we can implement this in Insight Maker and demonstrate the vectorization issue. Step 1. Create a new Insight Maker model. 1. Go to Insight Maker, https://insightmaker.com. 2. Create a new model. Step 2. Define variables. Create the following stocks, flows, and variables in your model. Stock population. Initial value initial population. Flow births. Equation population birth rate 1, population / carrying capacity. Variable birth rate. Equation 0.1, or any reasonable constant. Variable carrying capacity. Equation 10, 20, 30, 40, 50, this is the vector of carrying capacities for each insect. Variable initial population. Equation 1, 2, 3, 4, 5, this is the vector of initial populations. Insight Maker model structure *. Step 3, run and observe. Run the simulation for a reasonable period, example 100 time units. Plot the population stock. The problem *. The population stock will now contain a vector of values, representing the population size for each insect. If Insight Maker's vectorization were perfect, each element of the vector would behave exactly as if it were simulated independently. However, because the calculations for each insect depend on the same time step, the order of the vector elements becomes important, and errors can happen with more complex models. Why this can fail? The bug. Order of calculation Imagine each insect's population update depends on the previous population of other insects. If the order of calculation isn't deterministic and consistent between time steps, then the behavior of the model changes. Insight Maker does not guarantee the calculation order of each element. How to debug, and partially solve, the buggy vectorization *. Here are several approaches. 1. Check the order of calculations *. Try sorting the vector based on the initial conditions or carrying capacity. This can influence the outcome. Try the following Insight Maker trick to see the calculation order by changing the equation of the birth's flow. Then click on the result of the trace to see how they are calculated. This will slow down the simulation. 2. Isolate the calculations. Create a second flow and variable to isolate the population calculations. This can mitigate the problem of circular dependencies in the same step. Variable population change. Equation birth rate 1. Population / carrying capacity. Flow births. Equation population population change. Step 4, a more complex example, disease spread in a network. Now, let's consider a more sophisticated scenario that really highlights the potential problems with vectorization. Imagine a network of people. Each person can be in one of three states. Susceptible, S. Infected, I. Recovered, R. The disease spreads from infected people to their susceptible contacts. Each person has a different number of contacts, a vector. Insight Maker implementation, conceptual. 1. Stocks susceptible, initialized with a vector of initial susceptible people for each person. Infected, initialized with a vector of initial infected people for each person. Recovered, initialized to 0 for each person. 2 parameters transmission rate, probability of infection per contact per time unit. Recovery rate, probability of recovery per time unit. Contacts, a vector representing the number of contacts each person has. E.g., 5, 10, 3, 7, 2. 3 flows infection. Equation susceptible contacts transmission rate infected / some, infected. Important this assumes that each person is exposed to the average infection level across the entire population. This simplification can be problematic if you want to model localized spread. Recovery. Equation infected recovery rate. The vectorization problem The major issue here is that the infection flow equation depends on the sum of the infected stock across all individuals. Because we are calculating the spread to individuals each time step, there is a circular reference of the value of infected that can cause errors. Solutions and workarounds Since we can't directly control the order of calculation within Insight Maker's vectorization, we need to consider a few approaches. Explicit loop, not recommended but illustrative. You could try to simulate each person individually using an explicit loop. This is highly inefficient and defeats the purpose of vectorization. However, it can be useful for debugging purposes to see how a correct, non-vectorized, version should behave. Insight Maker doesn't have explicit loop constructs like for loops, so this is often not a practical option. Aggregate model, simplification. Instead of modeling each individual, create an aggregate model with a single susceptible, infected, and recovered stock. This loses the individual level variation but avoids the vectorization issues. Delay functions and auxiliary variables. Using these functions can make calculations more efficient. For the infection flow, try using the delay function. It's not ideal for every scenario but might help in certain cases. Code example, Insight Maker, conceptual with problems. Here's the core part of the Insight Maker model's equations. Remember, this code is conceptual and demonstrates the pitfalls of vectorization, not a fully functional solution. Important considerations. Model complexity. The more complex the model, the more likely you are to encounter vectorization problems. Start with simple models and gradually add complexity. Testing and validation. Thoroughly test your models. Compare the results of vectorized models to simplified, non-vectorized versions to identify discrepancies. Alternatives. If vectorization issues become intractable, consider using other modeling tools, example Python with NumPy/SciPy, R, that provide more control over array operations and calculation order. You can use Insight Maker for smaller models, or for presenting models. Key takeaways. Insight Maker's vectorization can be powerful but has limitations. Circular dependencies and time-based functions are common sources of problems. Careful model design, testing, and validation are essential. Consider alternative modeling tools for complex or sensitive vectorized models. Always be critical and skeptical of the results of vectorized models, especially if they involve intricate dependencies. By understanding these potential pitfalls and employing careful modeling practices, you can mitigate the risks and leverage the power of Insight Maker's vectorization while being aware of its limitations. Good luck.